Alright, hey everybody, this is section 5 of chapter 5. We're going to be talking about solving exponential equations and our properties of exponential functions, using those properties in logs and ln and all that fun stuff. Okay, so first of all here, b to the x equals b to the y if and only if x equals y. Okay, so this first little rule right here will help us in most of our solving. So as I'm starting this first section, I'm going to write the equation so each side uses the same base, and then we'll set the exponents equal to each other once the bases are the same. Hopefully you've seen something like this before in Math 1, where you use the same base in these exponential equations. So for example here on A, we already have the same base of 2, which is awesome. So since they have the same base, that means x plus 12 is actually equal to 7x. And then we can just solve like normal. So subtract x both sides, we're going to get it by itself. So 12 is equal to 6x. And then divide by 6, so x is equal to 2. And then you're always welcome to check. In fact, I'm kind of overcritical with this, so I always check and I say, all right, well, 2 to the 14th power, so I have 2 plus 12 is equal to 2 to 7 times 2, which is 14. So obviously 2 to the 14th power would be equal to itself. Okay, let's look here on B. This one's a little different. We don't have the same base, but if I recognize some patterns and kind of got some number sense, then I can see that 125 is the same thing as 5 cubed. I'm going to verify that real quick. Yeah, 5 cubed is 125. And so this is 5 cubed to the x power. That's the same thing as 125 to the x power, equal to 5 to x minus 3. Now they have the same base, awesome. And then when I have power and power, this is really just multiply. So 5 to the 3x is equal to 5 to the 2x minus 3. Same base, so then that means we'll have 3x equal to 2x minus 3. Go ahead and solve, and we'll get x equal to negative 3. Okay, and you're always welcome to check. So I'll have 125 to the negative third is equal to 5 times negative 6 minus 3, which gives negative 9. And then if you remember, 5 to the third is 125, so 3 times negative 3 is your negative 9, so they are the same. And you can also type that into your calculator to check. Alright, let's look here at C, 1/10. This one's kind of trickier to find a similar base of 1/10. But if I keep in mind that exponent rule when I have negative exponents, I know 10 squared is 100, right? So if I want 1/10, then I'm going to use the idea of negative 2, knowing that it's a negative exponent, to actually evaluate 1/10 negative second power. That would be the same thing as 10 squared. So then that tells me 1/10 to the negative second power is 100. Now to the x is equal to 1/10 x minus 3. So now I have the same base. So we have negative 2x equal to x minus 3. Solve, get x by itself on one side. So negative 3x is equal to negative 3 divided by negative 3. And we get x equal to 1. And you can always verify that. You'd have 100 to the first, which is just 100, 1/10 to 1 minus 3, which is negative 2, and we already knew that 1/10 of the negative second is 100, so we're good. Alright, for purposes of time, we're going to go ahead and move along. D is very similar, just as a head start. If you'd like to try it on your own, you can pause the video, but I would change 36 to 6 squared, and then go from there. Make sure your 2 distributes to both of those when you're solving. Alright, next section is solving exponential equations with or using logarithms. So we're going to get the base with the variable exponent alone and then change to logarithmic form or take the log of both sides. Taking the log of both sides is actually where logarithmic form came from, if you want to kind of connect that idea. It's pretty neat. Okay, so looking here at number 1, in order to get rid of 6 and kind of undo this exponent, this is the cool thing about logs and why I like them so much. is I know if I take log base 6 of 6, this actually goes to 1. Nice. And we studied that in previous chapters. So what I do to one side, I do to the other. So I'll have log base 6 of 99 is equal to n. And then if you think about it, log base 6 of 99 equal to n is actually changing this to logarithmic form. Neat, right? Because your base 6, your exponent base is your log base, and then your exponent is your answer, and you take the log of what you're equal to, which is 99. So that's how we change to logarithmic form anyways, using the same solving skills. And then from here we can actually just use calculators. I've mentioned this previous times before in videos. To get a specific log base instead of just log base 10, you'll need to hit math, which is that third key down on the left side, that math key button, and then option A. You can hit alpha math, and that will give you option A if you want to, instead of arrowing down. And then you'll get 6 as your base, 99 what you're evaluating, and we have 2.6 approximately, held around to the nearest tenth. All right, number 2, we have 5 times 18 to the 6x power. Now we want to get the exponent and its base all by itself, and this just goes back to basic solving skills. Let's first divide by 5, so we'll have 18 to the 6x equal to 26 fifths. I'm just going to leave that for now for purposes, just simplifying purposes. And then to go ahead and solve, I know I can use log base 18 to get rid of 18. And what I do to one side, I do to the other. So I'll have 6x equal to log base 18 of 26 fifths. And you can change that to a decimal if you'd like, but I'm going to leave it as 26 fifths in the meantime. And then really we can just put this in our calculator and divide by 6, right, to get our x completely by itself. So I'm going to take log base 18 using my math option A. Okay, option A, and then our base is 18, and we have 26 divided by 5, enter. And that decimal is about 0.57. And we want to divide that by 6 to get x alone. So then we'll just hit divide by 6. So x is approximately 0.095. Okay, and just to check, because this is a crazy one, and the answer is really, it's a decimal, I'm going to plug in 0.095 into my x. So I'll do 5 multiplied by 18 to the power of 6 multiplied by 0.095. And then hit enter, and I get 26. Magic. That's what we love about math, right? All checked out. Okay, so go ahead and look at number 3 here. We want to get our exponent by itself, so subtract 3. 9n plus 10 equals 75. We want to get rid of our base. We can use our log base 9 that we've been practicing with. What I do to one side, I do to the other. So n plus 10 is now equal to log base 9 of 75. Okay, and then we can use our calculator from here and subtract 10. And this is just going to be a calculation in our calculators. Okay, so then I'm going to use math and then option A. Okay, and then we'll go ahead and put base 9, 75, and subtract 10, and I get negative 8.04 if I'm rounding. All right, next section, to solve an equation with